Continuity and differentiability exercise 5.6. We completed 2 questions. Now we'll find the derivative for the third parametric equations. X is equal to sin t, y is equal to cos 2t. So we have to find the derivative of this parametric equations. So let us write down given parametric equations. X is equal to sin t, y is equal to cos 2t. So what is the parameter here? T is the parameter. Right. Now we have to find dy by dx, right? We have to find dy by dx. So we know that when we have parametric equations, dy by dx will be dy by dt divided by dx by dt. Now we will label this as 1. So first we will write x is equal to sin t. We will get dx by dt, and here we will write y is equal to cos 2t. We will differentiate and we will get dy by dt. So x is equal to sin t. Since we want dx by dt, we have to differentiate. So differentiate both sides with respect to t, right? With respect to t, we have dx by dt is equal to d by dt of sin t. So therefore dx by dt, so derivative of sin t is cos t, and here we will get dt by dt. So we will not write that, we can just write cos t here. Now here y is equal to cos 2t. We want dy by dt, so we will differentiate. Differentiate both sides with respect to the independent variable t. We have dy by dt is equal to d by dt of cos 2t. So this implies dy by dt is equal to derivative of the cos function is minus sine function, right? That is minus sine 2t. And we should differentiate 2t because of the chain rule. We should also differentiate 2t. So therefore dy by dt is equal to, so we will get minus sine 2t, and derivative of 2t will be 2. Just rewrite this, dy by dt is equal to minus 2 sine 2t, right? So this is equation 2 and this is equation 3. So we will put these equations in 1, putting 2 and 3 in 1. Dy by dx is equal to, first we have to write dy by dt, so minus 2 sine 2t divided by, in the denominator it is cos t. So this implies y by dx is equal to, so here we know sine 2t, sine 2t is 2 sine t, so 2 sine t cos t. So when you have theta, I will write theta, but here we have t, so we will write 2 sine t cos t divided by cos t. Now therefore dy by dx is equal to, so here we will multiply, minus 2 times 2 is minus 4, cos t by cos t is 1, so we are left with minus 4 sin t. So this is the derivative of the function x is equal to sin t, y is equal to cos 2t. So we completed the third one. Now we will find the derivative for the fourth parametric equations. X is equal to 4t, y is equal to 4 by t, given parametric equations. X is equal to 4t, y is equal to 4 by t. So here the parameter is t, right? So t is the parameter. We have to find derivative of these parametric functions, that we have to find dy by dx. So we know that dy by dx is dy by dt divided by dx by dt. And we know that dx by dt should not be equal to 0. So let us label this as 1. So we want dy by dt, dx by dt, that we will get from these two parametric equations. So we will write x is equal to 4t and y is equal to 4 by t. So we want dx by dt, so we have to differentiate the function. Differentiate both sides with respect to which variable we have to write? T, which is the independent variable and which is the parameter here. So we have d by dt, dx by dt, d by dt of 4t. Now this implies dx by dt is equal to, so when you have d by dt of constant into t, so when we have d by dt of constant into t, so here t to the power 1, right? So here also t to the power 1. When you have t to the power 1, then we can write the constant. So dx by dt is 4. So this is 2. Now the next one, y is equals to 4 by t. We want dy by dt, so we will differentiate. Differentiate both sides with respect to t. We have dy by dt is equal to d by dt of 4 by t. Now this implies dy by dt is equal to, so derivative of 4 by t, so constant will bring outside and we will differentiate 1 by t, right? So therefore dy by dt is equal to 4 into, so derivative of 1 by t, derivative of 1 by t is minus 1 by t square, minus 1 by t square. So this is 3. So now we got 2 and 3. We'll substitute in equation 1, putting 2 and 3 in 1. Dy by dx is equal to, so first we have to write dy by dt. So we will multiply this, minus 4 by t square, then dx by dt is 4. Now this is equal to minus 4 by t square into, how do we write this one, whether we should write 4 or 1 by 4? So many have confusion on this. See, when you have complex fraction a by b divided by c by d, so when you have fraction by fraction, so how you are going to write it? A into d divided by b into c. So here you have fraction by fraction divided by 4 by, so there is 1 here, right? When you don't have anything, it means there is 1, right? 4 by 1. So now how we are going to write it? A into d, that is minus 4 into 1, then b into c. So in the place of c, b into c we have 4. right? So therefore dy by dx is equal to 4 by 4 will be 1. You are left with minus 1 by t square. So this is the derivative of the fourth parametric functions. So we completed the fourth one.